Hi everyone, it's time to take a look at using a set of two variable statistics, two variables in a set of data in order to make a scatter plot, and then more importantly find some information about the line that we use to predict that situation. So first of all, we're going to take a look at data that takes a set of brothers and sisters and looks at the height of the brother and the corresponding height of the sister. So I have the data here, and what we're going to do is first we're going to look for creating the scatter plot and finding the regression line, or the equation that we use to predict this value. So to do that, I have a chart set up over here that has the data. So you'll notice I have the brother and the sister. And because either one of those could be the cause and the relationship, I'm going to look back at the question and notice that it asks me later to predict the height of Damien's sister Tanya when they tell me Damien is 70 inches tall. So I'm going to use Damien as the explanatory variable, the brother, and look at the sister as the response variable. So when I set that up, I'm going to be talking about the brother as the x's and the sister as the y's. So first of all, let's just insert a chart, and we'll make it a scatter chart. So I'll go into the chart types and jump down to scatter plot, and then insert a chart of that data. So you'll notice I have brother and sister. The brother is going to be the explanatory variable, and the sister is going to be the response variable. If I go into view mode on this chart by clicking the little eyeball, I can hover over each one of these and see the point that corresponds with it. So this is 7169. Notice it's 71 on the x, and then I go up 69 over here. That is this point 7169 on our data. So the most important thing for us to do next is to be able to look at this data and decide what the regression line is, basically the best fit. So to me it looks like there is a line that's going through this data in a positive direction. So I am going to simply go into the advanced edit of this chart, and I'm going all the way down to the bottom to where it says Trendline, and I'm going to tell it to use a linear trend line. All right, an exponential trend line is one that's curved. A linear is one that's straight. And for the label, I'm going to tell it to use the equation. And just because I'll use it a little bit later, I'll tell it to show r squared. And you can make the color of the line whatever you want. I'll make it black, and then I will update this chart. So now I've got the line on here along with this equation. I'm also going to, just so that I can see this a little bit easier, I'm going to stretch this chart out a little bit. In the edit mode, I'm also going to put this stuff on the top. And I do that simply because it looks a little bit easier up here to read the equation than when it's stepped in here. I could have clicked on this and then put it on the bottom and have it down there as well. Either one. I just like it better where I can see it like that. So here is the equation that I have, and we're going to talk about that in just a second here. So 0.527x plus 27, and let's actually copy this if it will let me. See if it lets me. No, doesn't look like it's going to. So my equation was, let's see if I can remember it, y equals 0.527x plus, and I'll jump back over here, and actually I'll just drag it over so I can look at it while I'm writing it, plus 27.635. All right, so you will recall from our discussion of the slope and intercept before that this slope is telling me that that line is going in a positive direction. And once again, the slope is always the coefficient of x, so that's my slope. So when I'm looking at an equation y equals ax plus b, where A is equal to 0.527 and B is my intercept of 27.635. I'm going to use that information in order to predict the height of Damien's sister Tanya. All right, Damien is 70 inches tall. So I have to remember in here that Y was always my sister height and X was my brother height. So in order for me to do a prediction, I need to know how tall the brother was and simply plug that in. So I'm going to do this equation, Y equals 0.527 times 70, because that's how tall Damien is, plus 27.635. All right. So I'm just going to crunch those numbers on the calculator here. And I end up with a height of 64.525. Now I'm going to talk about something that I should have done right away when I did this. This line is my prediction line. So the one I have here, a lot of times in stats we put this little Y hat over here. So here I'm predicting that Y is going to be 64.525. So the height of the sister, my predicted height, is 64.525. All right, and we are going to look at and see if we have any actual heights of 64.525 when we look at that for someone who's 70 inches tall. So let's jump back over to our spreadsheet. All right, so here I've got this data again, and I'm going to look at it, and I actually have somebody here who is 70 inches tall. And their sister was 65 inches tall. I predicted that it would be about 64.525. So I'm really close in my prediction. But at the same time, if I would have been predicting a height for someone who is 71 inches tall, my predicted height is right here. In fact, I'm going to tell you, if I go back in here and put this into the equation, for someone who's 71 inches tall, my predicted height is about 65 inches. My actual data shows heights of 69 and 62 inches. That's about 3 inches lower and 4 inches higher than my predicted height. Okay, so even though I was really close for 70, I wasn't as close for at least the data that I have here, but that's why this is just a prediction line that goes across. So how close or how much can I trust this line? Well, we did have two things that we know about this line. One of them is called the correlation. All right, so if you remember, we can do equals coral and then say, well, here's our data for y, comma, here's our data for x, and hit enter. And it says that I have a correlation of 0.55. Which is a relatively strong correlation. But something that I put in here, and I actually don't see it now, and I'm going to go back into the advanced edit. Something that I put in here was to show the r squared. And I don't see it, possibly because it's just hidden behind this dot, dot, dot. So I'm hovering over this area that's got it, and you're going to notice the r squared is 0.311. I'm going to show you something that happens here. If I take this correlation and square it, I get 0.311. So here's a really interesting thing that we have here. So I have, let's extend this page a little bit. I have found out that my correlation was approximately 0.55, and this r squared value was approximately 0.31, which, and just double checking that, was approximately 0.55 squared. All right, so these two statistics kind of go hand in hand, and it's not always the easiest thing for us to understand. The correlation tells me that this looks like it's going to fit a line. What R squared really tells me is what percent of the variation is explained by my line y equals 0.527x plus 27.635. All right, it's really going through and saying, well, about 31% of all of the variation that occurs here is explained by that line. Again, it's just a measure of strength. So I can be relatively certain. I mean, I've got a pretty good chance, that my line is actually explaining the data that I'm seeing here. A couple of things to keep in mind, though. My data is not going to do a very good job of explaining somebody who has a brother who is 75 inches tall. Yeah, I've got a line and it shows me all the way out to here, but my spread of actual values that I have collected are only between 65 and 75 inches. I'm not going to trust it very much if I go shorter than 65 inches or taller than 75 inches that this is going to be an accurate description. So I'm really kind of bound in here. And there's a lot of reasons I might say that, yeah, I trust this. I've got the correlation value. I've got the R squared value. All right, so the last thing I want to show you is a couple other ways to get these exact same results. So moving this off to the side here. If I want to know the line estimation, there is a formula called line estimation that says here's known data y, comma known data x, and it gives me two numbers in here. I'll spread them out so you can see them. And you'll notice that the first number is my slope. The second number is my y-intercept. So it always gives me the slope and intercept, the same ones that I have in my equation here. I showed you how to do the correlation. Let's take a look at using the add-ons in the Excel Miner tool pack to do the same thing. We did correlation a couple times, so I'm not going to do that. Descriptive statistics tells me a lot about that as well. It does give me some of the R squared things again, but I'm going to show you the linear regression. Linear regression is just a fancy way of saying the best fitting line. So I need my data for y, highlight it and click. I need my data for x, highlight it and click. I did put labels in there because I included the first row, so I'm going to click the labels. I don't usually touch any of this stuff, but I'm going to put the output range right here. And I'm actually going to do a line fit plot and a residual plot, and we'll talk about the residual plot in a later video. So when I hit OK, it gives me the summary output, and now it's giving me two new plots. First of all, in the summary output, it tells you here's what that R squared was, as well as this multiple R, which if you notice really is that correlation value. So it had a correlation of 0.55, it had an R squared value of 0.31, talks about some error things, but then it does give me the two coefficients right here. It gives me the x and the intercept. So the coefficient of brother, which was my x value, the number that goes in front of x, and that. So again, looking at that line, 0.527x plus 27.635. I also have, here is the example of the line fit plot, and you will notice instead of drawing the line here, it drew a predicted sister value, which is kind of nice because when I go over this, I can say at 70 we had a predicted value of 64.527. At 73, at 72, and it's nice because it gives you all of the values for the whole numbers that are in there. And then the red ones are the actual ones. So keep in mind the residual, the difference is going to be taking this value and subtracting the actual. So the predicted minus the actual. So in this case, 61.89 minus 59 to get the residual. And then we have this thing called a residual plot, which basically takes this exact same line and flips it on its side so that it's straight. So you can see exactly how much above and below. It kind of shows you, half of the data is above and half the data is below. And you'll see a little bit about the residual plot a little bit later. But that is how to calculate the residual or the best fit line, how to use that best fit line in order to make a prediction for some value, and then also how to interpret how accurate your prediction is, which is basically evaluating the R-squared value.